السلام علیکم اسٹوڈنٹس. آج سافٹ ویئر ریکوائرمنٹس انجینئرنگ کا دوسرا لیکچر ہے اور آج ہم گزشتہ لیکچر سے آگے کے کانسیپٹس پڑھیں گے. لیکن اس سے پہلے کہ آج کا لیکچر شروع کریں گزشتہ لیکچر کے بارے میں کچھ باتیں ہو جائیں. پچھلے لیکچر میں ہم نے سافٹ ویئر ریکوائرمنٹس کا بیسک انٹروڈکشن حاصل کیا تھا اور ہم نے دیکھا تھا کہ ریکوائرمنٹس کیا ہوتی ہیں اور ریکوائرمنٹس کتنی اقسام کی ہوتی ہیں اور یہ کہ ریکوائرمنٹس کی کچھ مثالیں ہم نے دیکھی تھیں اور تفصیل سے ہم نے فنکشنل ریکوائرمنٹس کے بارے میں بات کی تھی. فنکشنل ریکوائرمنٹس کیا ہوتی ہیں، فنکشنل ریکوائرمنٹس کی ایگزامپلس رکھی تھیں، فنکشنل ریکوائرمنٹس کی امپورٹنس کے بارے میں ہم نے بات کی تھی. آج وہ باتیں دہرانے کی ضرورت تو نہیں، لیکن آج سے ہم فنکشنل ریکوائرمنٹ سے آگے جو مختلف اقسام ہیں ان کی بات کریں گے. تو بیفور وی کنٹینیو لیٹس ریکیپ what kind of requirements we had. We talked about 5 different kinds of software requirements: functional requirements, non-functional requirements, domain requirements, inverse requirements, and design implementation constraints. And we talked in detail about functional requirements. Today, we will focus on non-functional requirements. Now, as the name suggests, these are non-functional requirements. They do not capture any functionality of the proposed software product. یہاں پر ایک انٹرسٹنگ کویشچن ارائز ہونا چاہیے آپ کے ذہن میں کہ اگر یہ نان فنکشنل ریکوائرمنٹس ہیں یا یہ ایسی ریکوائرمنٹس ہیں جو کہ فنکشنالٹی سے جن کا کوئی تعلق نہیں ہے، تو ان کا سافٹ ویئر پروڈکٹ میں کیا دخل ہے؟ یہ کیوں ایک اہم حصہ ہے سافٹ ویئر ریکوائرمنٹس کا، یا ایسا اہم حصہ ہے کہ جن کے بغیر ہم کلیم کرتے ہیں کہ سافٹ ویئر پروڈکٹ صحیح طور پر کام نہیں کر سکتے. اس ڈسکشن کو ہم آج لے کر چلیں گے اور نان فنکشنل ریکوائرمنٹس کے جو مختلف اسپیکٹس ہیں ان کو ہم ڈیٹیل سے کور کریں گے اور بائی دی اینڈ آف دس لیکچر یو وڈ بی کنونسڈ with the importance of non-functional requirements. So let's move on and see where we are going. Again, looking at non-functional requirements. Non-functional requirements ایسی requirements capture کرتا ہے، یا یہ title ایک ایسی set of requirements کو capture کرتا ہے جس کا directly functionality کے ساتھ تعلق نہیں ہوتا. پھر کس چیز کے ساتھ تعلق ہوتا ہے؟ اس کے اوپر غور کرنا چاہیے کہ اتنی امپورٹنٹ کیٹیگری ہے لیکن پروڈکٹ کا اس کے ساتھ کوئی تعلق نہیں ہے. ہم نان فنکشنل ریکوائرمنٹس میں ایسی چیزوں کو شامل کرتے ہیں جو کہ اس کے کوالٹی ایٹریبیوٹس ہوتے ہیں، جو کہ اس کے پرفارمنس ایٹریبیوٹس ہوتے ہیں، جو کہ اس کی ایفیشنسی اور بعض اور کیریکٹرسٹکس کے ساتھ تعلق رکھتے ہیں. اور یہ فنکشنالٹی تو کیپچر نہیں کرتے لیکن کسی بھی سافٹ ویئر پروڈکٹ کا ایک بہت ہی اہم حصہ ہوتے ہیں. اور اگر میں یہ کہوں کہ ان کی اہمیت فنکشنل ریکوائرمنٹس کے برابر ہوتی ہے تو یہ غلط نہیں ہوگا. اور آگے ہم آج کے لیکچر میں تفصیل کے ساتھ دیکھیں گے کہ ان میں کیا اسپیکٹس ہیں جو کہ ان کو اتنا امپورٹنس دے رہے ہیں. فارملی ہم دیکھتے ہیں کہ نان فنکشنل ریکوائرمنٹس کیا ہوتی ہیں. موسٹ نان فنکشنل ریکوائرمنٹس ریلیٹ ٹو سسٹم ایز اے ہول. ان کی انڈیویجول امپورٹنس اتنی زیادہ شاید نہیں ہے لیکن وہ ایز اے ہول ہولسٹکلی کلیکٹیولی ایک سافٹ ویئر پروڈکٹ کے لیے بہت امپورٹنٹ ہوتے ہیں. اینڈ دے انکلوڈ کنسٹرینٹس آن ٹائمنگ، پرفارمنس، reliability, security, maintainability, accuracy, the development process and standards, etc. اب جیسے کہ 5-6 کیریکٹرسٹکس ہیں کہ یہ کیریکٹرسٹکس جو ہیں، یہ ایٹریبیوٹس جو ہیں، یہ کوالٹیز جو ہیں نان فنکشنل ریکوائرمنٹ کنسیڈر ہوتی ہیں. اب اس میں سے کسی ایک کو ہم مثال کے طور پہ لے لیتے ہیں. परफॉर्मेंस को ले लेते हैं। अगर सॉफ्टवेयर प्रोडक्ट की ये रिक्वायरमेंट है कि उसको एक सर्टेन लेवल पे परफॉर्म करना है, सर्टेन टाइमिंग कैरेक्टरिस्टिक्स शो करने हैं, तो वो अगर एट्रीब्यूट या वो क्वालिटी हम प्रोडक्ट में नहीं डालते या वो प्रोडक्ट में अवेलेबल नहीं है, तो वो प्रोडक्ट यूज़ करने के काबिल नहीं होगी, ऑल्दो उसकी फंक्शनैलिटी के साथ डायरेक्टली कोई ताल्लुक़ नहीं। तो मैं बात कर रहा था कि सिक्योरिटी एट्रीब्यूट को भी हम कंसिडर कर सकते हैं एज एन एग्जाम्पल ऑफ नॉन फंक्शनल रिक्वायरमेंट। Because of the popularity of different networks, including the internet, security has become a real concern and issue for different software products. And companies are very concerned about maintaining the security of their products and of their computer systems. Again, this is not directly a functionality of the software product. But since the businesses are forcing companies to use the internet for performing their activities and providing services to the customers, they are very worried about how to keep their systems secure and virus-free. So they are investing a lot of money in this, and all of these things are covered under the non-functional requirements for a product. And so there are many examples which we will study today. And throughout the semester, we will see that the importance of non-functional requirements highlighted time and again. We will continue with our discussion of non-functional requirements. As I have said before, as a whole, in non-functional requirements are more critical and important than individual functional requirements. They capture what is known as the emergent behavior of the system as they relate to the entire system. Emergent system or emergent behavior is that behavior which is shown by the collectiveness of different attributes or characteristics. And all the non-functional requirements act together to provide that emergent behavior. There is no comparison with functional requirements as far as non-functional requirements are concerned. They both complement each other to make a workable and successful software product. You cannot say that the non-functional requirements are competing or are against functional requirements as far as the time and resources of the requirements engineers are concerned. They must both be given due attention, and resource allocation must be made by the project manager to successfully gather and discover the true nature of the requirements as far as they are needed in the software product. In the last lecture, I talked about the importance of functional requirements, and I had said that most developers or most requirements engineers and customers focus most of their attention in gathering functional requirements. And that is unfortunate in a sense that many a times they forget to give due attention to non-functional requirements. As we will see later on, the importance of non-functional requirements highlighted throughout this lecture today. So another important characteristic that non-functional requirements bring to the product is that they capture the emergent behavior of the system, of the software product. And that is a very important part of how the software product is used and how it is perceived by the users of the software product. Many a times a product is wonderfully developed, has all the necessary functionality, but it is ignored and not used by the users because one of the non-functional requirements is not fully implemented. For example, if it is not easy to use, if a product is not easy to use, there are many customers who will choose not to use the software product, and they would ignore the functionality that is captured in that product. And that is unfortunate, because not paying due importance and not giving due time and resources to non-functional requirement has probably made all the functionality go in waste. So moving on to another concept, and that is the non-functional requirements. Non-functional requirements must be given due share and importance in the requirements gathering process or in the requirements engineering process. What happens is that when you gather the non-functional requirements, you make them a part of the software architecture and framework for the software product. You don't do that for functional requirements. You have to build non-functional requirements into the architecture of the software product. If that is not done, then you cannot add non-functional requirements later on. One can add functionality to an existing software product, but one cannot add, for example, security to an unsecure software product. One cannot add reliability to an unreliable software product. One cannot change performance characteristics of a software product. One cannot make a software product easy to use without making major changes in an existing software product. So it is very important that these non-functional requirements be captured and brought into the requirements model, so that then they can be used for the development of a wonderful architecture for the software product. As I've probably said before, failure to meet one non-functional requirement may make the whole system unusable. For example, if the product is wonderful, it's calculating, considering a payroll example that we talked about last time also, and the requirement is that employees can submit their duty sign-ins to the web, and for one reason or the other, the security is not up to the mark, and someone comes along and changes the data, making the product vulnerable, and once the management comes to know about it, they will throw away that product. And all that money and resources and effort that has gone into development of such a system would be wasted. And all of us who have used software product know that there are many products which are not easy to use. They are not sometimes easy to install, and as a result, one doesn't want to use those products. Now, these things are not related to the functionality of the software product, but these are captured in the non-functional requirements. So the importance that I want to highlight today is the value attached to the non-functional requirements. And most students and professionals sometimes fail to understand the importance of these very important kind of software requirements. Continuing with our discussion, let's take an example of an aircraft system. For example, a company has built a wonderful aircraft, a commercial aircraft which can carry hundreds of passengers from one country to the other, one city to the other. But if that aircraft does not meet a reliability requirement, then it will not be certified as safe to fly. All that investment, all that effort, all that time that was spent and energy that was spent in building such a large aircraft would be wasted if it is not certified as safe to fly. Similarly, in control systems, the performance characteristics are very important. And if they are not met, these systems cannot be used in real life. Consider the example of a petrol pump, a service which is provided by many companies. And if it is not safe, it may have petrol, but if it is not safe to operate in that area, then the owners would have to shut down for one reason or the other. So again, emphasizing the importance of non-functional requirements, let's move on to some more useful discussion on non-functional requirements. Now, how do you find these non-functional requirements, or where can we look for these non-functional requirements? Non-functional requirements arise through user needs because of budget constraints, because of organizational policies, because of the need of interoperability with other software and hardware systems, or because of external factors such as safety regulations, privacy legislation, etc. Stating the needs again, non-functional requirements arise through user needs, which can be related to the performance. They can come because of budget constraints, and budget constraints have nothing to do with the functionality. Because of organizational policies, again, some organizations may require their employees to develop software in such way. Because of the need of interoperability of other software and hardware systems, a company may have existing software and hardware which must be used in continuation with the new software, or because of the external factors such as safety regulations and privacy legislations, and many countries are making such regulations and legislations which restrict or put constraints on usage and implementation of software product. Moving on to the next concept, let's look at this picture which shows that non-functional requirements are of three types. Non-functional requirements can be product requirements, they can be organizational requirements, and they can be external requirements. Product requirements specify the product behavior. Organizational requirements are derived from policies and procedures in the customer's or developer's organization. So requirements that are coming from the organizational side are included in the organization requirements, and the external requirements are those which cover all requirements which are derived from factors external to the system, external to the software system, and external to sometimes the organization and its development process. So this diagram or this picture shows clearly that the non-functional requirements are majorly categorized into three different types: product requirements, organization requirements, and external requirements. Now let's look at the product requirements. Product requirements, as you can see on the slide, has four major categories. They are usability requirements, they are efficiency requirements, reliability requirements, and portability requirements. These requirements are non-functional requirements, and efficiency requirements can be further categorized as either performance requirements or space requirements. Usability requirements deal with how the product is to be used. Efficiency requirements, as I've said, and you can see on the slide, has two subcategories: performance requirements and space requirements. These requirements deal with the performance issues and with the hard disk space issues, memory management, and other kinds of requirements. And the reliability requirements are those requirements which make a product or which show a product how reliable it is, or put constraints on the reliability aspect of the software product. Similarly, the portability requirements are those requirements which put constraints on the software product to make it portable on different platforms. These platforms can be multiple operating systems, can be different kinds of hardware, can be different kinds of processors, and things like that. They can be different kinds of language compilers and so forth. Again, you can see that none of these really have anything to do with the functionality of the software product, but they are part of the requirements model, and on the basis of these requirements, which are broadly categorized as product requirements within the non-functional requirements, are very important part of the requirements model, and also on the basis of these requirements we can develop the architecture of the software product. Let's take up some examples of product requirements. We take up two examples. The first one is that the system shall allow 100,000 hits per minute on the website. This is related to the performance aspect of a website-oriented software product. This has really nothing to do with the functionality of the software product, but it says that it allows you that up to 100,000 users can log on to a particular website. The second example is the system shall not have downtime of more than 1 second for continuous execution of 1,000 hours. This is an example of the reliability requirement. As you can see, that the statement says that if your software product runs continuously for 1,000 hours, system cannot be down for more than 1 second after that. Or you can say that for 1,000 continuous execution hours, you are allowed to shut the system for only 1 second. This is a very high reliability requirement for a software product. Okay? So again, this does not capture any functionality of the product. This does not tell you that this product does this for you, but it only says that if this is not met, then the product may not be useful to its users. Let's move on to the next type of requirement, which are organizational requirements. As you can see on the slide, the organizational requirements consist of 3 subcategories: standards requirements, implementation requirements, and delivery requirements. The standards requirements deal with the different kinds of software development and IT standards that are being followed by different companies. These standards are usually developed by well-established non-profit organizations and also some for-profit organizations as well. For example, IEEE and Association of Computing Machinery develop certain standards. Similarly, there are other military standards, and there are some commercial standards as well. So any constraints imposed on the software product to use these standards would be categorized under this heading of standards requirements. The implementation requirements are those requirements which constrain us on using certain implementation aspects of the software product. For example, there can be a requirement saying that this particular product will be developed using a .NET framework. Although it is not appreciated much in the IT community that such constraint be imposed on the design side of the software product, but this is a reality that companies would like to continue with the technology that they're using, and so they can require developers to ask for such a requirement. And as far as their businesses are concerned, this is a very legitimate viewpoint which must then be honored by the developers. And there can be other implementation issues or implementation requirements, like using the object-oriented technology or using data flows or other kinds of design methodologies. Similarly, the last category is the delivery requirements, which deal with the delivery of software system, the kinds of media and the services that are associated with the delivery of the software product, also then captured here in the organizational requirement. So recapping this slide, the organizational requirements are subcategorized as standards requirements, implementation requirements, and delivery requirements. Moving on to the examples of the organizational requirements, let's take up two examples. Number one, the system development process and delivery documents shall conform to the MIL standard 2167A. Now, this is a requirement which belongs to the standards requirements subcategory of the organizational requirements within the non-functional requirements. It simply states that all the development processes and all the documents that must be produced should conform to the military standard, MIL standard 2167A, which is an established standard for software development. The next example is that any development work subcontracted by the development organization shall be carried out in accordance with the capability maturity model. Capability maturity model, or CMM, is a standard which is developed by Software Engineering Institute in USA, and it is being used in many companies worldwide, and Pakistan has also started a drive to get the companies certified so that their processes conform to the CMM model. And in the last several years, many companies have done so, and their development models are now certified by the CMM model. So again, this would be a non-functional requirement and would come under the standard subcategory of the organization requirement. Let's look at the third category of external requirements. External requirements can then be further subcategorized as interoperability requirements, ethical requirements, and legislative requirements. And legislative requirements are then further categorized as privacy requirements and safety requirements. The interoperability requirements state or capture those requirements which deal with the interoperability with other software and hardware systems. You see, organizations develop software piece by piece, and there can be many existing products already in use which are working fine as far as the functionality of the products are concerned. They may not be using the latest technologies, but they are meeting the requirements and their functionality is fine as far as the customer needs are concerned. And a company wouldn't want to throw away those products just because they are not using the latest technology. So it is then becomes a requirement for the new product developers to ensure that the new software products can interoperate with existing products if there is a need to do that. The second category of external requirements are ethical requirements. Ethical requirements deal with the culture of the country and the company and sometimes of the customer. Without going into much detail about this, I would just like to say that since the establishment of the Code of Ethics by IEEE Computer Society and Association of Computing Machinery, this is also a very important aspect of non-functional requirements. The third category deal with the legislative requirements. There are two subcategories of this: privacy requirements and safety requirements. Increasingly, worldwide and also in our country, legislation is being developed to put constraints for the benefit of the customers and the users of software products. Since this is a relatively new domain, the companies are getting familiar with it at a slower pace than they do, for example, in other areas or other application domains. Increasingly, governments and local governments and federal governments are putting constraints like usage of internet or ensuring that the customer data is kept safe and is kept private, and it is not published without the consent of the customers to different parties. For example, there's a very real concern that a hospital which has computerized its operations and all the patient's data is available the patients would never want their data to be made available to anyone who wants it. There is an issue of privacy, and so governments are acting in the interest of the citizenry and in the interests of the customer, so that there are constraints put on to the developers and companies which have access to this data. And similarly, there are safety requirements on the usage of the equipment, on the usage of the software product. So moving on, and we'll look at the examples of the external requirements. We will take up two examples. The system shall not disclose any personal information about members of the library system to other members, except the system administrators. This requirement states that individual members of the library do not have an interest in finding out about other members, which books they have checked out, or which magazines they have checked out, or whatever, or finding out about their personal information, because a lot of personal information is kept in the library system. For example, a library system would typically have not only the name but also the addresses and telephone numbers of its customers. So why would the library staff allow this to, or give it out to other members? So the individual members of the library have a privacy right to restrict the information that they have provided to the library, that this information should not be given out to other members of the library, or to the outside world for that matter. However, the library staff does have a right to know about the telephone numbers and addresses to contact the library members, so that they can be contacted for one reason or the other, like an overdue book may be wanted back or something like that, or the library fees may be overdue. So these are privacy concerns which must then be stated very clearly in the requirements document, and they are captured under the non-functional requirement. The other example that I'd like to mention is the conformance to the national and local laws. As I had said before, that increasingly governments are making regulations on usage of computing technologies. For example, the use of licensed products is an international norm and requirement. However, there is still a lack of understanding and appreciation by the customer base in a lot of societies, so that they continue to use pirated software products. However, there can be regulations, and there can be local laws which prohibit that, and similarly usage of other software tools in conformance with the national legislation. For example, companies in a country may have developed a wonderful piece of software, but that country does not have good relations with another country, and the second country may restrict the use of software developed by companies in that country. So summing up discussion on the types of non-functional requirements, I would like to say that standards and external requirements and organizational requirements and safety requirements and privacy requirements and legislative requirements are all very important part of the non-functional requirements. Proper care and attention must be given to gather these requirements and to later on develop an architecture based on these requirements. Let's now discuss some observations on a non-functional requirement. As we have seen, these requirements are sometimes not given due importance by the customers or even by the developers, because they are sometimes written as general goals by the customers. For example, one can say that I want a software product which is easy to use, and I want my product to recover from failure in a gentle way, or the recovery from the failure should be relatively easy or simple. Or I can say that the user response should be rapidly captured, and the software product should convey this to the user. And these are very difficult statements and also very easy statements. They are difficult to understand and they are easy to state. Okay? One can say that I want my product to be easy to use. Now, what does that mean? What is easy to use? How can you quantify that? Or rapid recovery from failure it depends from one perspective to another, or it varies from one person to another person. And similarly, the rapid user response can be understood and misinterpreted by different people. So, summarizing, I would say that non-functional requirements can be written as goals of the software product. Now, there are some issues with it which I would like to discuss in more details. Goals are open to misinterpretation. One can interpret a goal in many ways, and as a result, inconsistencies can arise and conflicts can arise within the requirement. Secondly, objective verification is difficult for goals, and this point is again based on the possibility of misinterpretation of the requirement. If one has to objectively verify or test a requirement later on in the product, if it is stated as a goal and not as a quantitative number, it is very difficult to test that later on. Another observation that can be made about this is that goals depict the priorities of the customers. Okay, and customers find it easy to convey their wishes or their priorities in terms of goals. They would like their software product to be easy to use, but they don't know how to quantify it. Okay, so it is the responsibility of the requirements engineers to inform the customer that there is a possibility of misinterpretation and that they should try to make it as quantitative as possible. However, it is not easy to do so in all possibilities. For example, it is very difficult to state the maintainability aspect of the software product in a quantitative way. One would like to develop a set of measures or metrics which can be applied to the usage of to this attribute of maintainability. However, in reality, it is very difficult to state that my software product is maintainable from a scale of 1 to 7 and it falls on number 5, right? It is simply not possible to do that. So, stating that as a goal by the customer will inform the development team and the requirements team that they should give priority to this aspect of the non-functional requirement. Although there would be still some multiple interpretations would be possible by saying that I want this project to be highly maintainable or easily maintainable. but this tells the development team that this particular attribute of the product is important to the customer. As a result of misinterpretation, there are chances of conflicts within the non-functional requirements. And this possibility is fairly high, even higher than functional requirements. The possibility of having conflicts within non-functional requirements are high because information is coming from different stakeholders, and different stakeholders can give different information about different quality attributes. For example, different stakeholders can give different response times or failure tolerance levels information to the requirements engineers. Thus, it becomes fairly difficult for requirements engineers to quantify and to actually determine what is that is actually required. اس صورتحال میں جہاں پر مختلف جو اسٹیک ہولڈرز ہیں وہ نان فنکشنل ریکوائرمنٹس کے میں مختلف قسم کے اختلاف کی صورت میں کیسے اس کو حل کریں، یہ ایک ریکوائرمنٹس انجینئرس کے لیے ایک حقیقت میں ایک مشکل کام ہے، اس لیے کہ بنیادی طور پر ریکوائرمنٹس انجینئرز جو ہیں وہ ڈومین کے ایکسپرٹ نہیں ہوتے. However, they have acquired some information and some knowledge about the application domain, but still they are not domain experts. So they should consult independent domain experts to clarify this situation, تاکہ ایسا نہ ہو کہ جب ان کی مس انڈرسٹینڈنگ کی وجہ سے، کیونکہ انفارمیشن مختلف اسٹیک ہولڈر سے آپ کے پاس ریکوائرمنٹس انجینئرس کے پاس آ رہی ہے، ایسے نہ ہو کہ ان کی مس ججمنٹ کی وجہ سے ان کی مس انڈرسٹینڈنگ یا مس انٹرپریٹیشن کی وجہ سے ایک ایسا آرکیٹیکچر بعد میں بن جائے جس سے سافٹ ویئر پروڈکٹ جو ہے وہ صحیح طور پر یوز نہ ہو سکے. تو یہاں پر ریکوائرمنٹس انجینئرس کو خاص طور پر اپنے پروفیشنل ایتھکس اور انڈرسٹینڈنگ اور نالج کو اتنا انکریز کرنا چاہیے اور ایسے ایکوائر کرنا چاہیے سو دیٹ دے کین میک اے ویری گڈ ڈیسیژن. ایک اور اسپیکٹ یہاں پر امپورٹنٹ ہے اور وہ یہ ہے کہ ریکوائرمنٹس انجینئرس کا یہ بھی کام ہے کہ وہ نیگوشیٹ کریں مختلف اسٹیک ہولڈرس کے درمیان. مثلاً ایک ریکوائرمنٹ یہ ہو سکتی ہے کہ سافٹ ویئر جو ہے وہ صرف 4 میگا بائٹس کی ریم یوز کرے. ایک کانفلکٹنگ ریکوائرمنٹ ڈائریکٹ کانفلکٹ نہیں ہے، لیکن یہ ایسی ریکوائرمنٹ بھی ہو سکتی ہے کہ وہ ایڈا پروگرامنگ لینگویج میں ڈیولپ کیا جائے اور اس کی یہ فنکشنالٹیز اس کے علاوہ ہوں، اور اس کیس کے اندر یہ ممکن نہیں ہو سکتا کہ وہ سارا پروگرام جو ہے وہ 4 میگا بائٹس ریم کے اندر انسٹال ہو کر ایگزیکیوٹ ہو سکے. اس صورت میں ان ریکوائرمنٹس میں گو بظاہر ڈائریکٹ کانفلکٹ نہیں ہے، لیکن سیمینٹک ایگزیکیوشن وائز اس میں بہت کانفلکٹ ہے. تو یا تو یہ صورت ہو سکتی ہے کہ وہ نیگوشیٹ کریں اپنے کسٹمرز کے ساتھ، اسٹیک ہولڈرز کے ساتھ، کہ وہ ریم کی لمٹ بڑھا دیں، یا یہ کہ وہ پروگرامنگ لینگویج کی جو ریسٹرکشن ہے اس کو ریموو کر دیں. تو یہ جو نیگوشیشن سکلز ہیں یہ بھی ریکوائرمنٹس انجینئرس کو نہ صرف ایکوائر کرنی پڑتی ہیں بلکہ ان کی جاب کا یہ ایک نیسیسری حصہ ہے کہ انہوں نے کسی بھی ایسپیکٹ کے اگر وہ کانفلکٹ دیکھتے ہیں تو اس کو نیگوشیٹ کر کے اپنے کسٹمر کو انفارم کریں اس کے بارے میں کہ یہ ایک پاسبلٹی آئے گی جس سے آگے کانفلکٹس آنے کا بہت چانس ہے. اور اس صورت میں آپ نہ صرف یہ کہ کسٹمر کو ایجوکیٹ کر رہے ہوں گے बल्कि आप कस्टमर के ऊपर एक अच्छा इम्प्रेशन क्रिएट करेंगे कि वो आपकी प्रोफेशनलिज्म की दाद देगा कि ये वी हैव हायर्ड अ टीम विच who know their work and they know what they are doing, and that is very important to get the respect of the customer. Okay, so summing up the observations of the non-functional requirements, I would say that conflicts will arise within the different types of non-functional requirements. It is then the responsibility of the requirements engineers to negotiate with the stakeholders and to find a common ground so that they can wonderfully and beautifully remove all these conflicts within the non-functional requirements. Because if they don't do that, they are going to build a software architecture which is not going to be up to the mark and requirement and standard of high quality software, as well as it is not going to meet the requirements imposed by the customers. You see, the conflicts arise because number one, there are multiple stakeholders, and number two, the customers themselves are not fully aware of the possibilities and the potentials of computer systems. And one cannot blame them for this. This is the responsibility of the requirements engineers and the development team to educate and inform their customers. And once this situation is clearly understood by the customer, they can make the necessary changes in the requirements that will result in a consistent and non-conflicting set of requirements model. So as a result of developing a consistent set of non-functional and functional requirements, one can develop a consistent architecture which will then result in a high quality software product. Now let's move on to a very important aspect of non-functional requirements, and that is the representation of non-functional requirements in the requirements document. The requirements, whether they are functional and or non-functional, are recorded in the requirements document, and it is the responsibility of the requirements engineers to highlight the non-functional requirements so that they can have their true impact in the software architecture. Towards the end of the lecture, I would like to just summarize that today we have learned some information about non-functional requirements, their importance, their categories, and their subcategories. And in the next lecture, we will continue from this point, and we will talk about different metrics to determine the quantitative aspects of the non-functional requirements. Till then, Allah Hafiz. See you in the next lecture. Thank you.